Right, ladies and gentlemen, I promised it. Here it is, Electron Configuration. The first thing we have to know how to do, the first skill we have to cultivate is how to do an off-bow chart. So, what we do is we write 1 through 7. And then we write 2 through 7, leaving enough room for us to put letters in between. Then we do 3 through 7. And we do 4 through 7. Now, I know that they go S, P, D, F. S is 2 electrons. P is 6 electrons. D is 10 electrons. F is 14 electrons. So, S, P, D, F. Now it's just about knowing where to put the lines that go through. So, here's the rule. The rule is, see if I can get this focused really good. The rule is the first and second line only go through those two, through one apiece, right? 1s and 2s. Then from there on, 2, 2, 3, 3, 4, 3, 2, 1. That is how we draw an off bow. If you don't know the off bow, or you can't learn how to write an off bow, then you're going to have to learn about the periodic table and where we put various things on the periodic table, like the S block. Ooh, that's terrible. The S block, the P block, the D block, and down here is the F block. And remember that this squeezes in the periodic table. It goes right in here, right in here. Lanthanides and actinides, sorry. So I know to a certain degree, 1s2, the 2s2, 2p6, 3s2, 3p6, 4s2, and then this is not 4d, and I can look at the off bow and know that this is 3d, and then 4p6, or you can just go by the off bow chart. So from here on, we're going to go by this off bow chart. We're just going to do everything by the off bow because it's just easier. Okay. Configuration writing practice. Oops, sorry. So, I told you not to do uranium or lead. If I didn't tell you not to do uranium and lead, you can do them. I don't care. It's just a longer electron config. The first thing I have to know is how many electrons am I dealing with. So sodium, I'm dealing with 11. So I always write out the number of electrons I'm dealing with. And then strontium, I'm dealing with 38. And nitrogen, I'm dealing with 7 electrons. I wonder if I turn this light off, if it'll be better or if the glare will be worse. Well, only one way to find out. Is that better or worse? About the same. About the same, we'll just deal with the glare. Okay. So then I can put my periodic table to the side, and I can just start dealing with electrons. So I'm going to go down my off bow. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. So 1s2, 2s2, 2p6. That's 6, 7, 8, 9, 10 electrons. Remember, the coefficient, that's the shell number. The letter is the orbit. And the superscript is the number of electrons in that orbit. So in this case, I've drawn 3p6. So there are 6 electrons in a p orbit in the third shell. Here, I've already dealt with 1s2, 2s2, 2p6. That has dealt with 10 electrons. I need to deal with one more electron. After 2p, I go to 3s. So 3s1. I've dealt with all 11. 2, 4, plus 6 is 10, plus 1 is 11. And there's a way to check my electron config. So I'm going to go to sodium. 3s block 1 is where this is located. So that's the last part of the electron config is 3s1. Is that true? It is true. I have done it correct. All right. So let's do the next one. So where can I put this where it won't be in the way, but it'll be in the shot. So I have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, let's see, that's 2, plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30, and then after 3d, I go to 4p, 4p6, and then 5s2. 2, 4, 6 is 10, 12, 18, 20, 30, 36, 37, 38. 38 electrons. 5s2 should be the last, should be where it's located. 5s1, s2. That is where it's located. This is the s block. Remember, these 2 columns are the s block. These 6 columns are the p block. These 10 columns are the d block. 5, shell number 5, S1, S2. So I'm correct. All right, this should be really easy. Nitrogen, 1s2, 2s2, and I need to deal with 3 more electrons, so 2p3. Now let's check if we're right. Period 2, 2s1, 2s2, 2p1, 2p2, 2p3. 2p3, nitrogen. Yes, I'm correct. It is in the P123 block. So that's how we do configurations. For ions, it's no different. It's not any different for ions. You just have a different number of electrons. So instead of oxygen having 8 electrons, as it normally would, I do the opposite of the charge, which is -2. So I'm going to add 2 electrons. So this has 10 electrons. Iron has 26. I'm going to subtract 2 electrons. That's 24 electrons, right? Iron has 26 electrons. So if I subtract 2, I do the opposite of this, -2, 24 electrons. Boron. Boron has 5 electrons. If I subtract 3, do the opposite of the charge, then it has 2 electrons. Nickel. Nickel has 28 electrons. If I do the opposite of this, I subtract 2, I'm going to have 26 electrons. Potassium. Potassium has 19 electrons. If I do the opposite of this and I subtract 1, I get 18 electrons. Is that right? Am I all right? Yep, I'm all right. Okay, now I got to do electron configs for the various number of electrons. So again, I'm going to pull my off bow over. I'm going to go down my off bow. 1s2, 2s2, 2p6. Done. And I want to show you the things that are main group elements first. So I'm going to do these 3. I'm going to do 6, 8, and 10 first, because I want to show you something. So boron, 2 electrons, so 1s2. Potassium, 18 electrons, 1s2, 2s2, 2p6, 3s2, 3p6, 2, 4, 6, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, you notice that these ions Oxygen has 6 valence electrons, so it wants to gain 2 to have 8, which is why it went -2. And look, it ends in a noble gas, 2p6. It ends like neon does. Neon ends 2p6. And look, boron ends just like helium, another noble gas, 1s2. And look, potassium ends in 3p6, like argon. It adopts the stability of argon. It ends in 3p6. Ions, except for transition metals, are going to end like a noble gas. 1s2, 2p6, 3p6. And then we could just keep going down the line if we wanted to. But these are not like that. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 2, 4, 6 is 10, 11, 12, 18, 19, 20, 30. Oops, I went way over 30. So if I'm at 20 here and I need 24 electrons, I need 3d4. And you could ideally check it. You could say iron has 26 electrons, but I've subtracted 2, so I should end here. This is the third D block, 3. D1, 2, 3, 4. Yep, that confirms. And then nickel. I know I'm going to do just like iron. 2p6, 3s2, 3p6, 4s2, 3d. So instead of 24, I need 26, so I need 3d6. 1, 2, 3, 4, 5, 6. That's nickel -2. 2 electrons. So that's it. That's Electron Config page 1. It's really easy. You're just going down the off bow, so I go 1s down this route. So the first one is 1s2. And then I go back up the top and go down the second one, 2s2. And then I go back up the top. Then down the third one, 2p6, 3s2. I go back up the top and down the fourth one, so 3p6, 4s2. I go back up the top, 4s2 to 3d10. And then down to 4p6. And then down to 5s2. And then up to 4d10. And down to 5p6. Then down to 6s2. See what we're doing? We're just going down, 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 down. However far we have to go to take care of all the electrons. What I also like to do is to add my electrons. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30, plus 6 is 36, 38, 48, 54, 56. And that way I know if I have to deal with 17 electrons, it's 3p and 1 less, so 3p5. If I have to deal with 19 electrons, I know it's 4s1. It's 1 less than 20, 4s1. You can always subtract out electrons. So anyway, that's how we do electron config. Let's get on to the meat of the matter. Let's get on to the good stuff. Okay. So, number 11, how many valence electrons does this have? Well, I don't know what this is, and it doesn't matter, but I can use what it is to check. So 2, 4, plus 6 is 10, 11, 12, 18, 19, 20, 30, 34 electrons. But I don't care about that. They're asking me about valence electrons. So I go to the highest shell. Is 1 the highest shell? Nope. Is 2 the highest shell? Nope. 3? Nope. 4? Yes. 3? Nope. 4? Yes. So 4 is the highest shell, and I have to do as many 4s as there are. There could be an S, a P, a D, and an F to do my valence electrons. That's not really how valence electrons work, but anyway, what I know I do is I add these two amounts of electrons. So here I have 4 electrons. Here I have 2 electrons. 4 plus 2 is 6 valence electrons. 6 electrons. All right, we're just going to keep going. I feel like I've said this so many times today. All right, so how many neutrons? Oh, wait, first let's check our answer. 34 electrons. So what has 34 electrons? 34 electrons. So 34 electrons. Selenium has 34 electrons. And if I go to the top, how many valence electrons? 6. 6. I am correct. I've checked my answer. Lovely. Okay. Number 12. Hey, I'm going to do this video in 2 parts because I spent too much on the first part.